Thanks, Todd. So how many of you guys here work with weldment or sheet metal structures? Lots of us. So does this image look familiar? How about this one? So how painful is it to measure and align all those components before you start doing all your fixturing and your welding? Is that a costly part of your assembly and setup structure? Well, it doesn't have to be, because the tab and slot fixturing method is a good solution to that problem. So it used to be really time-consuming and tedious inside of SolidWorks to set up a tab and slot, but now in 2018, you can do it with one feature. So that works with your assemblies, your parts, and even your multi-body parts. So let's jump into the software here and see exactly what that looks like. So I have myself this airbag upper support here, and we can see it's a multi-body sheet metal part, and it's using tab and slot to try and align everything here. So in my sheet metal tabs now, I have this tab and slot command, and it is really quite easy to use. So the first thing I need to do is grab an edge, and that's where my tab's gonna go, and then a back face on where to terminate my slot. And you can see it's starting to give you a nice preview exactly where that slot's gonna lay out. So I have some offset points, so I have my purple point and my green point at the end, and I can set an offset. So maybe I need to avoid features or another edge there or something, so I can get these tabs and slots exactly where I need them to be really easily, all inside this property manager here. So I can set up equal spacing for them with X amount of instances, or I can get really custom with it and go in there and set up spacing for each one of those. I have control over the length of all of these tab and slots, as well as the height. So I can give it a blind end condition, or up to surface, or even offset it from the surface if I need it to protrude or anything like that. I have some corner treatments I can do to it, just to make sure that it has a nice easy fit in there. So I can put a fillet or a chamfer, and just like that, it will slide in. And the last part of my property manager here is just the clearance value. So I can put in different clearances for a tighter or looser fit for my tab and slots. So there is groupings as well. So if you've set up all of your property manager and you want to have a bunch of different edges for your tabs and slots, you can just hit our new group option, just like you would in weldments, and grab yourself a new edge and a new face to generate your tab and slot nice and easily there. So it works for weldment structures as well. So you can see here that the alignment of all these components is going to be really easy, because there's literally a hole for everything to fit into. It's only going to fit one way, and that one way will be the right way. So when you're done welding everything together, you don't look at it and you're like, oh man, that piece was backwards. It works with all of your patterning and mirroring tools as well, just like you'd expect any SolidWorks feature to do. So we can see I started with this tab and slot here. I used a circular pattern to pattern it around. And then on the left side there, another tab and slot, and then just mirrored that around. So it is a very functional tool right out of the gate. So Ryan here was working with these tab and slots, and he made these cool little business card holders. And they worked really good. They're balsa wood that he got laser cut. So then I was a little offended because it was my section, so I had to make something way bigger. So I made myself this big old birdhouse here. And I wasn't sure about how well those clearances were going to work. So I used about a 2 thou clearance, and you can see that I can slide these components in and out really easily and line these up just like that. And this thing fit together really snug. And just like Ryan did here, you can start gluing those very easily, just like that. So on my screen here, if we go back to the PowerPoint, I have a nice little video of how that got all assembled together, nice and easy. Pretty cool. Very cool, fun new feature. So previously that would have not been as easy and pleasurable to make, I'll tell you that much. So some additional sheet metal features that have been added is a normal cut feature and a suitcase 3-bend corner relief. So I have this hole up here in this piece of sheet metal, and it's not a normal cut. So maybe it was done as an assembly feature, or maybe using the indent tool, something where I didn't have that nice normal cut checkbox like you do with the extruded cut inside of a sheet metal tool. So now I just have this one-click normal cut button where I can grab this angled face here, and just like that, it will generate that face normal, so I can use a cutting tool really easily to make that. It also gives me a feature here in my FeatureManager design tree. So we have a new 3-bend corner relief, and that's the suitcase corner. So it comes with a couple options where you can define how much of the gap you'd like to fill. So for each one of those corners, I'm going to do something a little different here. So we can see we can have some of that gap filled, none of the gap filled, but it fills that corner really nicely for us. So in summary, the normal cut tool can normalize those sidewalls in your sheet metal models. The normal cut tool applies a normal cut feature, and that's independent from the tool that was used to remove the material initially. The suitcase corner relief creates a closed spherical corner without any cutouts. The sphere is based on the existing sheet metal parameters. So assemblies have had some nice updates aside from those performance evaluators that Todd was talking about. The linear pattern tool now has the ability to rotate instances. There's been some mating enhancements where you can temporarily hide faces with the Alt button and the new misaligned concentric mates, as well as the ability to automatically update our SpeedPaks when we're saving assemblies. So I'm back in my kitchen assembly here, and in this motorhome, we can sleep about 6 people, but my coffee mug stand here only has enough room for 1 mug, and that's not going to fly. I'm going to have some grumpy people in the morning. So I got to redesign this. So my linear pattern tool has this new checkbox where I can rotate instances. So as you can see, as I add these more instances, they start getting rotated around automatically. I don't have to put any angle mates in there, and I can set the angle to be exactly what I need it to be. And now I have enough space for coffee for everyone in my nice little tiny house that I'm going to be living in here. So my burner here isn't quite mated properly. So I'm going to show you the enhancements to that mate tool. So I'm inside my mate tool and I'm hovering over a face, and now if I hit the Alt button, I can temporarily hide that face. So before I'd have to kind of right click and maybe select other or select through geometry, but now that's been hotkeyed down to the Alt button. So I have my bolt pattern and my hole pattern, and they're not quite perfectly lined up here. So I'm going to make myself one concentric mate and then see what I have going on. So looking at this second hole, I can see I can't quite get that perfectly concentric. So what I have new is the ability to set up some misaligned concentric mates. So I'm going to come in here and I'm going to grab that. And I think I turned it off in my settings here. So if you don't want to create those misaligned mates, you have this nice option here to allow the creation of misaligned mates, which I had turned off. So let me come back in here and show you exactly how that works. So I have my first concentric mate, and now I'm going to try and make this second one lined up here. Cool. Oh, there we go. Allow creation of those mates. So there we go. Now I can grab my misaligned mate and I can throw it in symmetrically, and that will be just like my width mate there, and it'll kind of split the distance of all of those off centers, allowing me to line that up. So I didn't want to get lazy when I was designing, so I had that turned off. So you have that nice little option there, and this is also where you can set up your kind of updating SpeedPak options when you're saving your assemblies. So by default, you can leave it at none, or you can set it to every time you save, all of your SpeedPaks will update, or you can flag certain SpeedPaks to update while you're saving. So that'll save you from having to go in and update your SpeedPaks when you need to recheck your graphics. So just as a nice little summary here, the rotate ability inside of the linear pattern tool. You can temporarily hide faces, do your misaligned concentric mates, and automatically update those SpeedPaks. So the magnetic mate tool is a drag and drop method of moving your assemblies around. So it was brought into SOLIDWORKS in 2017, and it's a great way to position components in maybe a facility layout scenario. So in 2018, the tool's been enhanced even more, making it easier and more intuitive. You can cycle through connection points on your keyboards, you can have multiple ground planes, and easier access to locking and unlocking those magnetic mates. So I'm going to show you how this tool works now by parking my red Camaro up there in one of these parking stalls. So I have my little stalls set up as an asset, so they're going to have mating locations, and all of my vehicles here are set up as an asset. So as I drag this around, you can see all of these orbs are looking for something to mate to. So if I hit my closed square bracket, I can toggle my mating locations on the part I'm dragging, and my closed square bracket will rotate it on the component I'm mating to. So I can move them around and grab exactly where I want to go. And that's how I park my car every time, with a nice little drift like that. So when I move these around and I mate them into place, so let's park in reverse here, right by my mouse, I have the ability to lock mates. So I can lock that mate now and no longer be able to drag that asset around. So previously you'd have to come into your mates tool and lock and unlock your mates that way, but now SOLIDWORKS is making enhancements and is right in front of you in your graphics area. So we do have the ability for multiple ground planes as well, so we can go on our second floor or first floor with that model here. So the magnetic mate tool is that drag and drop method of mating your components that share a common ground plane, and it's a new tool that kind of keeps getting enhanced every year. So finally, exploded lines can be added automatically to exploded views. So let's check out what that looks like. So I have my exploded view here, and I have this new feature called Smart Explode Lines. So I can click on that, and every explosion step that I have, a line has been added. So by default, it's going to go to the bounding box center of each one of my components, but I can change that around and customize it. So I can drag this point and center it. And for these bolts here, I don't want the line going halfway through the bolt, I want it right to the edge, but I have a lot of bolts, so I can apply that change to all of those component instances, saving me a lot of rework. So these are smart lines as the feature entails, so any changes I make to those exploded steps, they're going to update automatically, making it really nice, really easy to use. So this new tool will make technical documents you create in Composer that much easier, but I'll let Ryan show you that a little bit later. So SOLIDWORKS 2017 introduced flexible new workflows when working with third-party design data like your Inventor files, your Solid Edge, or your CATIA files. 3D Interconnect streamlines collaboration with your customers and supply chain regardless of which CAD tool they're using. 3D Interconnect is much more than 3D translation. In fact, it virtually bypasses the entire translation process and allows you to work with CAD data in a variety of design tools. It's also intelligent and understands when third-party CAD data is changed within its native design environment by honoring face and edge IDs. So some enhancements this year is the ability to work with those neutral file formats like your step files and your IGES files. You can also read reference planes and custom properties, and then a whole bunch of additional information from your third-party files like assembly cut features, custom properties, material properties, and unconsumed sketches and curves. So now that we can work effectively with neutral and third-party formats, there's new ways in SolidWorks to leverage that data, and Ryan's going to show you that right now.
Great, thanks, Dane. So, yeah, I guess who here has ever touched an STL file or OBJ file? Okay, probably at least more than half the room here. So for those of you that don't know, I just want to talk a little bit about what mesh models are and then kind of why we should care about them, and then look at in the software the new enhancements for this year. So basically they're just a tessellated version of the geometry. So rather than working off true surfaces and solids in SolidWorks, we're getting a triangulated mesh made up of just thousands or millions of triangles. And the most common file formats that are out there are going to be your STL, OBJ, or newer ones like 3MF. So why should we care about them? Well, high technology basically. If you're doing any 3D scanning, like you see here, one of our Artec 3D scanners that we carry, trying to replicate objects or reverse engineer, those are going to be spitting out some type of mesh file format as an output. And then if you're doing any 3D printing or rapid prototyping, you're also going to be expecting, in this case as an input, an STL or OBJ file or the new 3MF files, like our HP 3D printer you see here. And it's getting to the point that these processes are so popular that there's even file sharing sites sprouting up just dedicated to mesh files, like some I have on their Thingiverse, common one. There's also mesh-based modeling software out there that previously we couldn't really collaborate with SolidWorks, So these are some of the reasons why we should care about mesh files. Basically, they're becoming more and more popular in many industries. And we'll look at some of the enhancements in SolidWorks 2018 for dealing with them. This is first kind of some quality of life enhancements, I call, where they're just easier to work with imported STLs. We can do some limited surface extraction directly from them. We can reference the mesh data directly now in SolidWorks Standard, and just many other little enhancements we'll take a look at inside the software here. So I'm just going to open up an STL file to get started. And they are unit lists, so you have to remember to open them in the right units. That's one thing to be aware of. And right away, if I switch to a shaded with edges view, you'll see that I can see all that tessellation there, right? All that data. And really, I think the thing you'll notice right away is if you go to any kind of a sketch in SolidWorks 2018, you're going to be able to hook on and directly reference that mesh data. So all of a sudden now, if you need to be able to take exact measurements from an STL file, or you want to start manually remodeling it, you'll have that capability to just reference the mesh as you go. Okay. There's other little nice things, like we can do section views. As long as you have the graphics only section option enabled, you can section a mesh file just like as if it's a solid. Okay. There's other things too, like appearances can be applied now to them as well. If you want to extract a surface from here under our surfaces toolbar, there's a function surface from mesh that you can add to your command manager like I have here. And this allows me to do surface extraction. It's really geared for prismatic parts, so I can only do planar surfaces, cylindrical surfaces, and spheres and cones. But it does work quite nicely, so I can just select just a few elements here from the top and tell that to extract a planar surface. And when I click calculate, it's going to look at that graphics body and try to extract out a surface for me. So that could be useful as a mating reference or as some other type of reference in an assembly potentially. If I try to extract a cylindrical surface, I can use this little paintbrush tool here, and this is just a handy way to select multiple facets. Notice I don't need to select a continuous row all the way around. I can just select a portion, and I have a tolerance slider there. If I click calculate, it will extract out that surface. And you'll really be able to see what I did here. If I hide the graphics body now, you'll be able to see those native surfaces that we've extracted from there. So this is what I considered kind of the more minor quality of life enhancements when working with these mesh files. The more major thing is for 2018, there's a whole new type of body called a mesh body. And this enables us to do direct mesh editing, essentially. So if you need to bring in STL files, modify them, and export them back out as an STL file again, for instance, to 3D print, this is a completely new workflow. So I'll show you the basics of it here. Suppose, this is a file, I only have the STL file, and I like it, but I want to make a modification to send it out to 3D print. I'll just work on it as if it's a SolidWorks model. Maybe I want to fill in this little area right here where there's a cutout. I can snap that directly to the mesh. And I'm going to do an extrude, but rather than merging it into the body, I'm just going to basically extrude a separate block. So this kind of goes back to the old school modeling, back when we used a lot of Boolean commands, merge and subtract and things like that. Because basically, if I had a way to get this solid body to also be the same type of body as this graphics body, then I could merge the two together, right? And it just so happens now if you right-click on any body, you'll have this new option, Convert to a Mesh Body. So the Mesh Body is a special body type within SolidWorks now. If we convert the graphics body to a mesh body, and also convert this solid body to a mesh body, all of a sudden I have new operations available to me. Like I can combine both of those, and now I have a merged together single mesh body that can be exported back as STL. Okay, so that's on a very, very simple example, but where the power of this comes in is on more complicated geometry. So I wanted to show here like a more organic part that could have come from a 3D scan. And if we look at the wireframe on this, there's a lot more triangles. So in the past, if we wanted to make any modification to this at all, we would have had to somehow turn it into a surface or solid, which is not an easy task. Now what we can do is, say I just look at the bottom half of this for now, I'll just hide the top. Right now this thing has no wall thickness to it at all. So maybe it was designed in mesh modeling software too, and that's great at making swoopy shapes, but it doesn't have Hole Wizard, doesn't have the other features to actually make something manufacturable. I might want to thicken this and send it off to a 3D print. So now we can convert that imported surface mesh to a mesh body, and we can actually use surfacing commands as well. We can thicken, we can shell, we can do a lot of different things here. So I can actually thicken this mesh body directly into something that I can go off and send to the 3D printer. Now it's actually got a wall thickness to it. So there's a lot of interesting possibilities here for anybody doing reverse engineering, 3D printing. I think you're going to find these enhancements really useful, and I'll kind of walk through some of the potential applications for them here. So basically we can go beyond even those minor modifications we saw there. I could bring in features like threads, convert those to the mesh body, merge them in. And basically, if you want the full list of commands, this is basically it here. We can do combines, intersects, splits. Say I want to go from a 3D scan to a 3D print, right? This is what we used to always have to do in the past, which is import in the mesh file and then somehow convert it to surfaces or solids if we wanted to do anything with it at all. And it's really that step that was quite troublesome. You were faced with really three choices. You could either manually remodel completely from scratch, or you could use an add-on like Scan to 3D, which comes in SolidWorks Professional. That would enable some automatic surface extraction. Or we have partner products like Geomagic that are really like the top end, if you want a more automated tool to just extract surfaces and solids. So that's still what you'll want to do if you want to take a scan in and turn it into an IGES or a STEP or some other real surface format that's shareable. But if you're just trying to do this rapid iteration here, where you're just going from 3D scan to 3D print, or even other applications like quick turn machining applications, they do sometimes machine from an STL file. It is possible. So if you're trying to do that workflow, you don't need to convert anymore. You can just bring it in and work on it and export it off as the native mesh file again. So we can bypass this step if you're intending to just go to 3D print. And that's what that process looks like. So I happened to actually take that bottle. I was able to work from the scan, add manufacturing detail to it, if you can see it right here. And this was printed on the HP printer. It's actually got kind of a functional prototype to it. So we've even got the screw-on cap and everything there. And with this material, we can actually, I don't know if you can see it on the camera, we can actually squeeze that pretty well there. So again, taking in just an STL file, that otherwise would basically be unusable in terms of SolidWorks, and being able to add in manufacturing details and things to it and come up with some kind of a rapid prototype. So it is probably a pretty narrow use case. Ways I see this for our customers being used would be medical industry, where they're doing a lot of personalized patient care based on like CT scans, customizing things to the patient. Any reverse engineering, quick turn manufacturing, where we need to really quickly make parts and it doesn't make sense to convert a real solid out of it. And just consumer products applications where you're scanning and iterating. So that's just a lot of new technology that's embedded in SolidWorks. I'm sure they had to do some really interesting things behind the scenes to make that possible. So hopefully it'll be useful to anybody doing 3D printing, 3D scanning going forward. Okay. And that really ends out all our detailed design phase here. So I think we're going to switch over to Dayne, and he's going to start talking to us about simulation.